Okay, now let's take a look at how we can calculate this. We see we have half the alpha on this side, half the alpha on this side, and 1 minus alpha, so that accounts for the whole 100% of our normal population. So if our population standard deviation is known, we're going to use this formula here. If it's unknown, we're going to have to use a different formula. Let's use an example of a 95% confidence level. So if our confidence level is 95%, our confidence coefficient will be 0.95. Now that means 0.95% is going to be within this shaded area here. That means we have 1 minus 0.95 to be our alpha. So that would make our alpha be 0.05. We have two tails, so we're going to divide that by 2, and we then have 0.025 on each side of our tails, and we have 0.95 in the middle. Now then we'll refer to the table to get our z. So we're going to be looking for a z of 0.025. If we look that up in the table in the back of our textbook, that gives us 1.96. It gives us a negative 1.96. Now, we know that it's identical. They're both on the same side. So if we have 1.96 on this side, we also have 1.96 on that side. Now, what if we wanted to do 99% confidence level? So if our confidence level was 99%, our confidence coefficient would be 0.99. What would our alpha be? It'll be our 1 minus our confidence coefficient. So that's going to make our alpha be 0.01. Now, we're looking at a two-tailed distribution, so we are going to divide that by our 2. And we're going to get 0.005 on each side. So we're going to have 0.005 here and 0.005 here. So what we're going to look up on the table is 0.005, and that gives us 2.575. So to connect this to figure out how to calculate our confidence for whatever data point or data sets we're looking for, we're going to plug this right here into our z here. So again, that number is going to come from the table that you'll get in your textbook, the normal distribution table. So we're going to put 2.575 here, and we're going to multiply that by our sigma divided by our square root of n. Now you may have noticed in both of these formulas we have a plus and minus. We have a plus and minus here, and we carry that plus and minus down here. Now why do we have a plus and a minus there? Because we have two sides. So we're going to have two numbers. This is going to give us a point here as well as a point here. And it's basically going to tell us our x is going to fall within that range 95, or in this case, 99% of the time. So this is going to break down even further. So we're going to have a negative that's going to go on this side of our mean, and we're going to have a positive that's going to go on this side of our mean. Now, this is the formula we're going to use for anything that's equal to. So if we're looking for an equal to, that's when we're going to divide by 2, because we are going to have two sides for each. That means our equal to means we're looking for the area within. Now, sometimes we might be looking for a less than or a greater than. So if that is the case, we're only going to be looking for one side. We're only going to have a one tail, which means we're not going to have to divide it by 2. We're just looking for alpha. Alpha is going to be all of this area right here. So if we're looking for a coefficient of 99, over here we're going to be looking for 0.1. We're not going to have to divide that by 2 because we're only looking for this one area here. Now, if our population standard deviation is not known, we're going to have to use a different formula, and that is what we call a t-base. And we're going to use the sample standard deviation for that calculation.